So hi, I'm Bob Thronson with Vigilent. Some people call us the Nest for data centers. We have our own brand also. But what we do is we optimize cooling dynamically in mission critical facilities. So that can be data centers or telecom exchanges, of which there are many, many, many thousands worldwide, so it's a big market. Where do I point this here?
Right left.
There we go. Hold on, zooming in.
Basically, hit right over.
Zoom out. It's just like,
Getting the slideshow on the screen.
there we go, sorry. So, so we solve two huge problems of mission critical facility operators. And the first one is what they're most afraid about is an outage downtime. Now, kind of interesting survey question, would you rather walk barefoot on hot coals than have an outage in your data center? 84% said yes. And yet 91% of these people are having outages periodically. So it happens no matter what they try to do. And the cost of that is very, very expensive. So, and the costs are going up. Here you can see the cost of an average outage at the bottom there is almost $700,000 per outage. And if you're in e-commerce, it can be many millions of dollars for an outage. So, what causes outage? There can be a lot of causes, but one of the most common is actually heat. So, IT equipment, servers need cold air to come in, otherwise they overheat, they break, and you have an outage. So here are examples there of public outages due to cooling and heat issues. There are many other examples where people have not wanted to go public, but this is a very common issue that people have in data centers. So, the first issue that we are sort of aware of and deal with is this outage problem due to heat in data centers. But the second one is that energy use is just huge and rising. So this data is a couple years old, but that's 30 gigawatts worldwide of power used in data centers every year. It's probably like 35 or 40 by now. And when you put that in dollars, it's over $30 billion a year spent in data centers on energy, and it's just going up. So, and as you know from a lot of these presentations, it's growing like crazy. So you would think to get rid of hotspots, you would need to cool more and spend more energy, right? But then they got this big issue with energy. They don't want to spend more energy. So is it possible to solve both problems simultaneously? And what that would look like is on the top, you may have in a data center a hotspot where there's not enough cooling and there's risk of a failure. And you want to increase the cooling to that spot to eliminate the risk of an outage. And at the bottom, you have areas of data centers that are too cold, you're wasting energy, and you don't want to cool those areas as much. You want to reduce the amount of cooling to just what you need. So can you solve both of these problems at once? Well, it's not easy to do. And the reason is, in a data center, this is a screenshot of a data center showing what we call an influence map. And you see there on the top, that's an air conditioner, cooling unit. And there are many of these in all data centers. And when you turn that unit on, the red is where it gets hotter and the blue is where it gets colder. And if you went around this room or any other data center, any other room, it's non-intuitive what happens. You turn on a unit here, you'd think it would cool around here, but no, the air blows around, it blows cold air this way, hot air that way, it interacts with other cooling units, and so it's a very, very, very complicated problem to solve. So, but that's what Vigilent does, is solve that problem. So we have a room full of PhDs that, figured this out. And the way we do it, if this were a data center, we'd put out some wireless sensors, takes about a day. That data comes back. We also instrument the cooling units into software, and that's the secret sauce, which figures out how every cooling unit affects every spot on the floor by itself, like when you turn it on or off or the fan up or down, and how it interacts with every other cooling unit. And it also figures out, in a dynamic environment where IT load in the room's going up and down, is how you manage that. So you eliminate all the hotspots, but make sure the energy use is minimized. And so the sensors feed that data into our AI engine where the software is. It figures out what to do. It issues control commands to the cooling units, which then the thermal environment's optimized, and the sensors provide this feedback loop where, if there's some change to the environment, the software notices it and relearns and re-optimizes the environment automatically without any human intervention. So it's machine learning optimization that's going on here. So the results, there's a lot of positive results. Verizon, we're in 84 of their data centers in North America and Europe. We're saving them so far $26 million in energy use. They're also using us to put their technology near the edge of the telecom network because we can tell them exactly where they have enough cooling capacity. TELUS in Canada, it's a smaller customer, but they've saved $1.5 million so far. This gives you an example of some of the customers that have gone public with their results with Vigilent. We have 235 deployments globally. You can see we are saving almost $25 million a year in energy use, eliminating hotspots, and we're actually a clean tech success story. As you can see on the bottom is the tons of CO2 emissions that the technology is automatically eliminating from the environment. So the best thing is the voice of the customer. This is Lloyd Switzer, SVP Network Transformation at TELUS. Said we deployed this in a week. We're able to dramatically reduce the amount of power we are using. It's pretty much a typical result of what our customers say and what they get. That's it. Thank you.